numerical method. So at the end of the lesson, students should be able to locate approximately a root of an equation. Find the root by using Newton-Raphson method. So you can read through the introduction here by yourself. So let's look at the first part. So finding the initial value. So the initial value of a root of fx equal to 0 can be located approximately by using graph, that is graphical consideration, and intermediate value theorem. So let's look at graphical method. So sketching the graph of y equals to fx. There are two ways to sketch the graph. If you are able to sketch y equals to fx, so the graph cuts the x-axis at a point, so that will be the root. Or you can split the function into two graphs. So we have capital Fx equal to capital Gx. So you let y equal to capital Fx and y equal to capital Gx. Plot the two graphs on the same axis. So the point where the two graphs intersect, that will be the root. Example 1. Show by drawing graphs the equation exponent x minus 5 equal to 0 has only one real root. So let fx equal to ex minus 5. Make sure it is equal to 0 first before you take out your fx. Draw the y-axis. Draw the x-axis. So it's minus 5 here, so the graph shift 5 units below. So find the line y equal to negative 5. Use proper scale. Okay, we use proper scale. So sketch the graph. So that's the graph of fx equal to ex minus 5. So this is 1, this is 2, origin. So the graph cuts x-axis at a point. Hence, the equation has only one root. The interval, the root lies in the interval 1, 2. Example 2. So draw the graph of y equals to 2 ln x and y equals to x over 2 on the same axis. So here we have the axis prepared earlier. So y equal to x over 2. So that's the graph. So label it. And then y equals to 2 ln x. So you should cut the x-axis at 1. So that's your graph of y equal to 2 ln x. The point where the two graphs intersect, that's where you get the root. So we have y equal to 2 ln x and y equal to x over 2. So 2 ln x equal to x over 2. 4 ln x equal to x. 4 ln x minus x equal to 0. Hence, the root of the equation 4 ln x minus x equal to 0 lies in the interval 1, 2. Algebraic method. By trial and error, find two values a and b such that fa and fb have different signs. So if you have fa to be greater than 0, fb less than 0, or fa less than 0, fb greater than 0. So the conclusion will be the root of fx lies within the interval of ab. So you can look at this graph below here. So here fx is greater than 0 above the x-axis. This is where you have the fx less than 0. So there lies a root. Example 3. Find algebraically the unit interval where the root of the equation with function fx equals to x cubed minus 4x minus 5 lies. You can choose any value. So let's say if I choose f1, f2, f3. So substitute into the equation. So 1 cubed minus 4, 1 minus 5. Substitute for the rest. So press your calculator. So you get negative 8, negative 5, 10. So this is less than 0, greater than 0. So between these two, we have changes of sign. Hence, the root lies in the interval 2, 3. Example 4. So take out the function. So make sure the right side is 0. So fx equal to cos x minus 0.5. So this is a trigo function, trigonometry function. So change the mode to radian. Substitute f. So given the interval 0, 1, so f0 and f1. So cos 0 minus 0.5, cos 1 minus 0.5. So press your calculator, so you get 0.500, negative 0.960. This is less than 0, greater than 0. Since there is changes of sign, hence the root lies in the interval 0, 1. Example 5. So similarly, so bring everything to the left side. So we have 2 power of x minus x cubed equal to 0. So again, make sure the right side 0. So then only you have fx equal to 2 power of x minus x cubed. So again, you are given the interval between 1.3 and 1.4. So substitute f1.3 and f1.4. So 2 power 1.3 minus 1.3 cubed. 2 power 1.4 minus 1.4 cubed. So press your calculator. So here you get 0.265. So here you get negative 0.105. So this is less than 0, this is greater than 0. So since there is changes of sign, hence the root lies in between 1.3, 1.5, 1.4, sorry. Show. Newton-Raphson method. So first of all, you need to make sure your fx is equal to 0. So the right side must be equal to 0. So the formula for Newton-Raphson is xn plus 1 equal to xn minus f of xn over f prime of xn, where n starts with 1, 2, and 3. If your first value is x0, the next will be x1, x2, etc. It follow through. If the first value is x1, so it will be x2, x3, etc. So it's just the notation. So the first step for Newton-Raphson is for you to find f prime of x. Example 6. Use Newton-Raphson method to solve the equation x plus ex equal to 0, correct to 3 decimal places. Initial value x0 equal to negative 0.5. So if you look at the equation, you can see here the right side is equal to 0 already. So write down your fx. So fx equal to x plus ex. F prime of x, that will be 1 plus ex. So x0 equal to negative 0.5. So next will be x1. So the formula xn plus 1 equal to xn minus f of xn over f prime of xn. So x1 will be negative 0.5 minus, so use bracket, so negative 0.5 plus exponent of negative 0.5 over 1 plus exponent of negative 0.5. So you press your calculator, so you will get it to be negative 0.5663. So if you look here, we have 4 decimal places. So since the question asks us 3 decimal places, so during workings it must be 4 decimal places. Continue the iteration for x2, x3. So negative 0.5663 minus, so whenever you minus something with 2 terms, so make sure you use bracket. Plus exponent of negative 0.5663. So you will get it to be negative 0.5671. Again, to 4 decimal places. Similarly, for x3, so we have negative 0.5671. Since the two values are the same, hence we stop the iteration. Hence, the root is negative 0.567 to 3 decimal places. Example 7. Show that the equation of 2 sine x minus x equal to 0 has a root between x equal to 1 radian and x equal to 2 radian. So note that this is 1 radian, 2 radian. Why? Because the function is a trigo function. Find the root of the equation by using Newton-Raphson method, correct to 2 decimal places. So take out the function. So make sure the right side is 0. So fx equal to 2 sine x minus x. So f1, f2. So substitute into the equation. So make sure you use proper brackets. Okay. So get the value. So this will be 0.682. This will be negative 0.181. This is greater than 0, less than 0, since there is changes of sign. Hence, there is a root between 1 and 2 radian. So next will be the Newton-Raphson. So find your f prime x. So that will be 2 cos x minus 1. Choose your x naught. So x naught will be 1 plus 2 divided by 2. So that will be 1.5 radian. So we're going to use x1. Next will be x1. So substitute 1.5 minus 2. So make sure you use bracket. 2 sine of 1.5 minus 1.5 over 2 cos of 1.5 minus 1. So press your calculator. So you get 2.077. So since the question asked for 2 decimal places, so give the value here in the workings to 3 decimal places. Must extra 1 decimal places. So continue with x2. So x2 we will have 1.911. Okay. Continue with x3. So 1.911, substitute again. So x3 is 1.896. So after 3 substitution, so we need not to do substitution anymore. So x4, you just press your calculator to get 1.895. So if you look at these two values, so if I make it to 2 decimal places, I would get it to be of the same value, which is 1.90. Here also will be 1.90 for 2 decimal places. So hence, that's our answer. The root is 1.90 to 2 decimal places. So example 8. Show that the equation 2x ln x minus 5 equal to 0 has a root, lies between 2 and 3. Use the Newton-Raphson method to find the root. Correct to 3 decimal places by using 2.5 as the first approximation. So that is your x naught. So x naught is 2.5. So take out the function. So make sure it's equal to 0. So your fx is 2x ln x minus 5. So substitute f2, f3. So 2 ln 2 minus 5, 3 ln 3 minus 5. So use your calculator. So negative 2.227. So here will be 1.592. So you see here, we have 3 decimal places. So 1 less than 0, 1 greater than 0. Since there is changes of sign, hence there is a root between 1, 2 and 3. Hence shown. So next we're going to use Newton-Raphson method. So find your f prime x. So how do you find your f prime x? We need to use the product rule. Okay, so this is your u, this is your v. This is your u, this is your v. So u, 2x, v, differentiate ln x, 1 over x, plus ln x, differentiate 2x, you get 2. So simplify, you will get 2 plus 2 ln x. So that is your f prime x. So state your x naught given 2.5. So we're going to do the iteration. So next will be x1. So x1, 2.5 minus, so again, so fx 2 times 2.5 ln of 2.5 minus 5, 2 plus 2 ln of 2.5. So we have the answer to be 2.6092. So next, do your x2. So similarly, 2.6092 minus, so you get x2 will be 2.6080. Still not the same, so find x3. So again, substitute. So you do the process, substitute. So we have x3 to be 2.6080. So now we get the same answer, the same value, so we can stop the iteration. So hence, the root is 2.608 to 3 decimal places. Example 9. So sketch the graph of y equals to ex, y equal to 2 minus x, where x less than 2 on the same axis. Get the first approximation x0, where x0 in between 0 and 1. Hence, by using Newton-Raphson method, solve the equation for x less than 2. Correct to 3 decimal places. So, highlight the 3 decimal places. So first, you need to sketch the graph. So, let's draw the axis. So we have the axis here. So this is y-axis, x-axis. So for y equals to 2 minus x, x0, y equal to 2, y0, x equal to 2. So make sure you have proper scale. So not to forget, your x is less than 2, so up to 2 only. So this is y equal to 2 minus x. Next, we're going to sketch y equal to ex. So x0, y equals to e0 equal to 1. So this is your graph of y equal to ex. So make sure it is less than 2. So from the intersection of the graph, so let's approximate the value. So let's say x 0.4. So next, by using Newton-Raphson method, solve the equation. So we have exponent of negative x equal to 1 over 2 minus x. So 1 over ex equal to 1 over 2 minus x. So cross multiply 2 minus x equal to ex. So ex plus x minus 2 equal to 0. Hence, your fx is ex plus x minus 2. So for Newton-Raphson method, so we need to get the f prime x. So ex plus 1. So write down your x0 again. So x0 is 0.4. So x1 0.4 minus, so use bracket. So e of 0.4 plus 0.4 minus 2. So exponent of 0.4 plus 1. So we have the value to be 0.4434. So make sure you give your answer to 4 decimal places during workings. So x2, so substitute similarly. So we have 0.4429. So continue again for x3. So we have here 0.4429. So you can see here we have the same value. So hence the solution is 0.443 to 3 decimal places.